Good morning, everybody. I'm going to take you through the process today of doing a battery load test when you don't have a true battery load tester. This process is just as effective, although there's some precautions that we have to take when we go through this process. Remember that a battery is a storage device for electricity, and it stores it in the form of chemical energy. At the beginning, we compared electricity to water in a storage tank, and we said that the pressure in that storage tank could be present even when the water is not flowing from that tank. If we open a valve in that tank and water starts to flow out, the water will remain under pressure while water is flowing out of that tank, provided there's a good storage, a good supply of water. Well, the same is true for a battery. Testing the voltage of a battery strictly tests the electrical pressure at that battery. To get a true test for that electrical pressure, we have to create a current flow from that battery and see that the battery maintains its pressure, its voltage, while current is flowing from the battery. Now, a load tester is one way to do that. We apply a set load to that battery. We load it to 1/2 of the battery cold cranking rating. On this particular battery, this is a 700 cold cranking amp battery, so we would load this battery to 350 amps, and we would run our test for approximately 15 seconds, and our hope would be that the battery would not drop below 9.6 volts, and that when we took that load away, that the voltage would come back up above 12 volts. The battery would recover properly. A bad battery might read 12.6 volts when it's just sitting here, when we measure the voltage. But if we were to put a load on that battery and the battery is not good, we're going to see that voltage crash very, very quickly. So we're going to be doing a battery load test without an actual battery load tester, both by necessity, because the battery load tester is locked up in the building and I can't get to it. But in addition to that, this will be a good test that you could do at home. Now, I'm going to use the LabScope only because I can screen capture on the LabScope. This does not have to be done with a LabScope. It can be done with a very inexpensive multimeter. You would set this multimeter to the 20 volt DC scale, and you would put your leads on your battery. I currently have the leads set already on this battery and connected to my LabScope, again, because of the fact that I can screen capture. That's the only reason for doing that. The other thing that we're going to do is we're going to make it so that this vehicle will not start. In order to run this test, we have to disable the starting of this vehicle. We're going to have to crank it over, but we don't want the engine to actually start. The reason being, we're going to use the load from the starter to place a load on our battery. So to do that, remember, an engine needs 3 things in order to run. It needs fuel, it needs spark, and it needs compression. If we take away one of those 3, the engine will not run. We've done that before in the case of compression tests. The simplest way to make this engine not run is to take fuel away in the case of this particular vehicle. What I've done is I've gone into my fuse and relay panel, and I've located, looking at the panel, I've located the relay for my fuel pump. All right, so now that we're into my fuse panel, there's a couple things that actually I want to point out to you that are a little bit concerning here. We see some debris that's left behind in our fuse panel. This is an indication that we had something living that was making its way into our fuse panel here too, so that's a little bit of a concern as well. You can see we have some acorns and some fur and some other things that I'm not going to mess with right now that are in this fuse panel. So that's something we want to pay attention to also. Unfortunately, when we have a vehicle that's not driven a real lot, we do have to be careful of that. And the materials that wires are made out of on today's vehicles are very tempting for animals to, such as mice, to want to chew on them. So we want to make sure we pay attention to that. So the fuel pump relay for this particular vehicle is this relay. Remember, relays are just simply electronically controlled switches that, in this case, enables the fuel pump to run. So by disabling my fuel pump, no fuel is going to get to my engine. The engine should not start. So it's going to crank over, but it's not actually going to start. We may initially get a quick start, but then it should stall after that, and then we should be able to go ahead and perform our test. So I'm going to go ahead and unplug my relay and continue with my test. In order to run this test, I'm going to crank the engine. I don't want to crank for 15 seconds. This is where we have to be careful. A starter motor is a motor that is not meant to run for a long period of time. And we can actually damage the starter motor if we do this test for too long a period of time. So I'm going to limit it to about 10 seconds. I'm going to count out to 10, and I'm going to watch my battery voltage. I want to see a drop of no lower than 9.6 volts, and then I want to see recovery back up above 12 volts. You would see it digitally on your multimeter screen. We're going to see it on our LabScope screen. All right, so as you can see, we are on our computer. We're connected to our LabScope. We're going to go ahead and open up our LabScope software, and I'll expand this out. And notice we see a voltage reading from the battery of right around 12 volts. Our scale is set at 5 volts per division. So you see that our line is just between our second and third line. Now, we want to see this will work well because we want to see this drop no lower than our second set of grid lines here, which is going to indicate that the battery is staying right around 10 volts, no lower than 9.6 volts during the crank. Now, we may see an initial start when we first begin this process. The reason being there may still be fuel pressure. So I'm going to go ahead and I'm going to crank the engine, and we're just going to see if it does start. Okay, so we got an initial startup, basically just burning whatever fuel is left out of the system. So now we're going to go ahead and crank. Notice we're at, again, about 12, just over 12 volts. And we're going to watch the drop of that line. Now, you'd be watching it on the screen of your multimeter. We're going to watch the line on the LabScope. Oh, we got another start. We'll finish burning the fuel out of there. We'll try this again. Okay, so notice during our crank, our voltage is hanging pretty steady. We're going to count out about 10 seconds. And when we release our key, we're back up to right around 12 volts. Slightly lower than where we started because batteries have something called a surface charge, but we are very, very close to the voltage that we originally started at when we began this test. And that's what we want to see. We want to see the battery drop no lower than 10.6 volts and recover above 12 volts. That's an indication that this is a healthy battery. Okay, so once we've confirmed that we do have a healthy battery and the engine cranks over, a couple things I want to point out about that are important. This test will only work if you have a cranking condition. So there are times where this may not be that productive. If you have a situation where the engine is not cranking, it's really difficult to try to do this test, and you may have to disconnect the battery and actually connect it to a true load tester and perform a load test on it that way. But in certain circumstances, this will work for you. The last step in this process is we want to make sure that we go ahead and we reinstall our fuel pump relay. And we want to confirm once we do that the engine does start, if it will actually start. If it's a no start condition, then obviously it's not going to. That's a mistake that you can make in the troubleshooting process. Don't build in additional problems. So for example, having a relay unplugged and now you go forward with troubleshooting your no start condition, and you end up finding out that, wait a minute, we had a relay unplugged. We have no fuel pressure, for example, and we start going in a direction of fuel when really the reason we had no fuel pressure is because we had unplugged the relay, and the true problem could end up being an ignition related problem, let's say. So we want to make sure that we're not building in our own problems as we go through and troubleshoot. So that's the process for load testing a battery when you don't have an actual load tester. And hopefully you enjoyed that, and we'll pick up with some of the other tests that we can do on batteries and starting systems as we go through this lesson.